Okay, this is the key to section 3.1 part 2, and on this worksheet you're given two quadratic functions. There's this one and then there's this one, and you want to graph these quadratic functions. Now these two quadratic functions are in what's called the vertex form. So remember, the vertex form, or the standard form, looks like this. Here's standard form, sometimes called vertex form. So you have f of x equal a times x minus h squared plus k. And so the vertex would be hk. Now remember, in a previous lesson, if you look at the binomial is being squared is x minus h, so h is your k. So if it's x plus a number, remember you got to rewrite as x minus a negative number. Okay, so in here, if you look at this right here, if you think about this, the vertex is not 2, negative 9, so you got to be careful. So remember, it's got to look like this, x minus h. So you may want to rewrite it like this to help you. So it's x minus a negative 2 squared minus 9. So x minus a negative 2, remember, is the same thing as x plus 2. So h is this negative 2. So this is your h, and this is your k. So the vertex is negative 2, negative 9. Okay, now remember, the domain for any quadratic function is all real numbers. So that's negative infinity to infinity. So as you go, so remember, just a real quick sketch of this. So your domain is, your vertex is in the third quadrant. A is 1 here, which is positive, so it means your parabola opens up. So look like this. And so as you go from negative infinity to infinity, you're going to get all real numbers for your x values. So your domain is from negative infinity to infinity. Now the range, see, this is your vertex right here, negative 2, negative 9. Then your range, you can do that without even looking at a formal graph, just looking at a sketch. So your range is going to go from remember, you go along the y-axis, so that's your set of y coordinates. And so if you go along the y-axis, you should start touching a graph at this vertex. Now remember, your range is a set of y values, set of y coordinates. So that smallest, that's a min. This vertex is a min. And the smallest y value is negative 9. So you're going to say bracket negative 9 to infinity. All right, now all quadratic functions have a y-intercept. So all quadratic functions have a y-intercept. You'll notice that regardless of whether it opens up or opens down, no matter where the vertex is in the plane, it will cross the y-axis. So you can find the y-intercept. Remember, to find the y-intercept, you can let x equals 0. So if I let x equals 0 and I plug 0 back into x, I get the y-intercept will equal, remember, f of x means the same thing as y. So it's going to equal 0 plus 2 squared minus 9. Well, 0 plus 2 is 2. 2 squared is 4. So I get 4 minus 9, which is a negative 5. So the y-intercept is a negative 5. Now, it did not indicate to write the intercepts as an ordered pair, so I'm just going to say negative 5. So there's the y-intercept. All right. Then it says to find the x-intercepts. Now, to find the x-intercepts, remember, that's where the graph crosses the x-axis. Now, you may or may not have x-intercepts. To help you determine whether you have x-intercepts or not, look at the rough sketch. So remember, the vertex was in the third quadrant. A is positive. Remember, that's a positive 1. So A is positive, so it means your parabola opens up. And so notice you do have x-intercepts. The graph will cross the x-axis. So let's find it. So to find the x-intercepts, you're going to let y equals 0. Now, notice in the direction it says, when finding the x-intercepts, round to the nearest tenth when necessary. Okay, so when I let y equals 0, remember, f of x means the same thing as y. I get this side right here, x plus 2 squared minus 9 equal f of x, which is 0. That's y. That's 0. And so remember, in a previous lesson, I think it was in chapter 1, you have to remember you were going to use a square root property here, so you have to bring the 9 to the other side, so you get x plus 2 squared equal 9, and then remember, you can use the square root property, so that's where you have to use a square root property. And so I'm going to go ahead and rewrite this over. You get x plus 2 squared equal 9. Then you took the square root of both sides. Don't forget the plus or minus though. So you learned that in a previous lesson. And so when you square and then take the square root, those two things are inverses of each other, so they undo each other. So you get x plus 2 equal plus or minus 3. Square root of minus 3. Alright, and so notice that, remember when we talked about solving quadratic equations in chapter 1, this number right here is rational. So when it's rational, you're going to split it apart like this. X plus 2 equals 3, x plus 2 equals a negative 3, and then solve for x. So notice I went from a quadratic equation to 2 linear. So I'm going to subtract 2 from both sides. So I get x equal 1. Over here I subtract 2, and you get x equal negative 3, and a negative 2 is a negative 5. So these add up to be 0. When I combine like terms, these are zeros. Okay, so there's your x-intercepts. So I did not need to use a calculator on this one to find the x-intercepts. Alright, so let's go ahead and graph this. So negative 2, negative 9 is right here. The axis of symmetry, let's go ahead and draw the axis of symmetry. That's going to be that dotted line. That's going to help us to draw a symmetric graph. The y-intercept is negative 5, so that's here. And the x-intercepts are 1 and negative 5. So right here and right here. Now just make sure that these x-intercepts are symmetrical about the axis of symmetry. So you see how this x-intercept is 1, 2, 3 units from the axis of symmetry? This is also 3 units from the axis of symmetry, so always look at that. So 3 units, 3 units. Now remember, you need 5 points. I want you to use 5 points. So you have your 2 x-intercepts, you have the y-intercept, you have your vertex. To find the 5th one, use the y-intercept. So the y-intercept is 2 units from the axis of symmetry. So the other point needs to be 2 units. So it's symmetrical about the axis of symmetry. So reflected about the axis of symmetry. Reflect this point about the axis of symmetry. So 2 units, 2 units. And then all you do now is draw your graph. Make sure it looks like a parabola though. Don't draw segments. Make it curve like a parabola. And then this side, make it look symmetrical. If it doesn't look symmetrical, make sure you erase and redo this. Okay, so there's the graph. Alright, number 2, same thing with number 2. So the vertex here, see how this is already x minus 3? So 3 is your h, so my vertex will be 3, 5. So this is your k, 5. So that's your vertex, so 3, 5. Now again, the domain, if you even look at this, remember the domain for quadratic functions, all quadratic functions will be all real numbers. So as I go along the x-axis for the domain, so if I look at negative 100 right here, I'm going to get a y value, I'm going to get a point on the graph. If I look at negative 1000, when x is negative 1000, I'm going to get a point on the graph. It will be way up there, a large y value, but I get a point on the graph. So I'm going from negative infinity all the way in the same thing. So 5,000, if x is 5,000, I'm going to get a point on the graph, and so on. So just remember, when you're dealing with quadratic functions, the domain is always going to be all real numbers. So negative infinity to infinity. Alright, now the range depends on where the vertex is and whether the graph opens up or down. So let's do a rough sketch of this. Just like we did this. Let's just think about a rough sketch of this. So the vertex is 3, 5, so that's in the first quadrant. Let's say it's here. The A is negative 2. So since A equals negative 2, so A determines whether the graph opens up or down. So since A is negative 2, which is negative, the parabola opens down. Okay, so it opens down. So something like this. So notice I am going to get x-intercepts. Okay, and so let's find the range. So remember that the arrows are pointing down. So when you do the range, you're going from, remember, to find the range, you go along the y-axis. You go from negative infinity up. So this is pointing towards negative infinity. So you go from negative infinity all the way to, and then you stop here. This is where you stop. Label that point though to help you. So remember, you are looking at those the range, which is a set of y coordinates, y values. So you're going from negative infinity all the way to this point, which has this y value. So the range will be from negative infinity to 5 with a bracket. Now to find the y-intercept, just like we did before, we're going to find the y-intercept. That's where the graph crosses the y-axis. When the graph crosses the y-axis, x is 0. So we're going to let x equal 0. And so I get negative 2 times 0 minus 3 squared plus 5. All right, 0 minus 3 squared, 0 minus 3 is a negative 3. Negative 3 squared is 9. 9 times negative 2 is a negative 18. So make sure you get negative 18 here. 0 minus 3, remember order of operation, do parentheses first. So 0 minus 3 is a negative 3. Negative 3 times itself is 9. 9 times negative 2 is negative 18. Plus 5. Hey, good morning. You get negative 13. And so you get y-intercepts negative 13. The x-intercepts, you're going to let y equals 0. And so you set this equal to 0. So you get negative 2 times x minus 3 squared plus 5 equals 0. Alright, so you're going to solve for x. You use a square root property. So you can bring this 5 to the other side. And then you divide by negative 2. And so these negative 2's divide out, and so you can get x minus 3 squared equal a negative 5 divided by negative 2 is 2.5. So go ahead and write it as 2.5. And then you use your calculator when you take the square root of both sides. So I'm going to take the square root of both sides. Plus or minus, you're going to get x minus 3 equal plus or minus the square root of 2.5. Alright, now this is irrational, so we're going to approximate this. So x minus 3 is approximately equal to, alright, square root of 2.5. So square root 2.5 equal, so it's about 1.6. So you get a positive 1.6 and a negative 1.6. And then adding 3, you get the x-intercept is approximately equal to 4.6. Adding 3, the x-intercept here is approximately equal to, let's see, 3 minus 1.6, 1.4. So those are your two x-intercepts. Alright, now let's use the vertex, which is 3, 5. The axis symmetry goes to the vertex. Go ahead and draw the axis symmetry. The y-intercept is negative 13. Okay, I don't have enough room, so let's just expand this. 11, 12, 13. So here's the y-intercept. The x-intercepts are 1.4. So let's say 1.4 is about here. And 4.6, which is about here. And just make sure that these two look symmetrical about the axis symmetry. So here's 4 points, you need one more. So if you looked at this y-intercept is 3 units from the axis symmetry, so I'm going to go 3 units this way. 1, 2, 3. And then you just graph. And this is it. So there's the graph. Alright, so that's going to take care of this one.